Hello student, I am Ankit Sharma. Today going to discuss about standard deviation. Friends, we know that standard deviation is a absolute measure of dispersion. Friends, dispersion is that statistical technique which find deviation of the series data variables by which we can understand the dispersion of data. We also know that measure of dispersion can classify in two ways: absolute dispersion and relative dispersion. Absolute dispersion give us knowledge about deviation and range. We can understand quartile deviation, mean deviation, standard deviation, and by the relative dispersion we can measure coefficient which compare two series, more than two series. We can find easily coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation. Friends, in this part we are going to study standard deviation and its coefficient. Friend, standard deviation is square root of the arithmetic mean of the square deviation. By this definition, we can understand three things. First is that square root, standard deviation is a square root of arithmetic mean of the square deviation. Means there are three things: square root, arithmetic mean, and square deviation. Standard deviation was introduced by Carl Pearson in 1893 and also known as mean error, mean square error, and root mean square deviation. Friends, standard deviation is a most commonly flexible technique to measure dispersion, which has advanced statistical tool to find deviation. And the term standard is assigned to measure deviation because standard deviation overcome the shortcoming of ignoring the algebraic sign plus and minus of individual deviation from mean. Friend, it is important that when any measure, it is plus or minus, is squared up, the resulting product is always plus. For that, we are saying it is standard deviation. Let me start with example. Standard deviation is denoted by Greek letter small sigma and can determine by the following formula. In individual series, friend, we know there are three series: individual, discrete, and continuous. In individual series, we can use formula sigma deviation divided by n, or sigma x minus mean squared up divided by n. We know d is denoted by deviation, and we find sum of square of the deviation from its mean. By indirect method, friend, in indirect method we avoid the effect of finding actual mean and using assumed mean and applying following formula: sigma dx square divided by n in under root, or square root of sigma deviation square divided by n, where deviation x equal to x variable minus assumed mean. Let we solve an example. Friends, we are taking an easy example. Find out standard deviation of the mark obtained by 10 students. Serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and marks 10, 18, 16, 30, 24, 12, 20, 15, 25 and 5. Let me solve the problem. First, we arrange this in serial number like marks like this, and thereafter we assumed a value. We are taking here 20 as a assumed mean, and then after it we will find deviation. Deviation means variable x minus assumed mean. 20 minus 10 minus 20, then here minus 10, and then 18 minus 20 minus 2, 20 minus 16 minus 4, 30 minus 20 plus 10, 24 minus 20 plus 4, 12 minus 20 minus 8, 20 minus 20 0, and 20 minus 20 0, 15 minus 20 minus 5, 20 minus 25 minus 20 plus 5, and in last minus 5 minus 20 minus 15. Then after we find square of this deviation. You can see 10 square is 100, 2 square is 4, and then we can easily find all these. Then we will sum all the things. Here you can see sigma deviation x equal to minus 25, and sigma d squared is equal to 575, and here we can write it by indirect method. At first at all we assumed a value, okay, or marks as assumed mean, and will find deviation by variable x minus assumed mean, which is called deviation x. Now we added it and we find sigma dx equal to minus 25, sigma dx square equal to 575. Let we applying formula. Sigma, small sigma means standard deviation. This is sign equal to sigma dx square upon n minus sigma dx upon n whole square. We will find square root of these things. Okay, we are putting the value here, you can see, and we will solve it. 575 divided by 10 will get 57.5 minus 25 divided by 10, it is minus 2.5 squared up. Then we will find this, and when solving this we will get it, and we will find square root of this. Friends, it is individual series. If we are going to calculate standard deviation of discrete series, then the following steps should be followed. First, one of the value in the series should be taken as squared mean. Deviation are found out from the assumed mean, and deviation are multiplied by their respective frequency, then totaled as sigma fdx. Each fdx is multiplied by dx to find product fdx square, then total and find sigma fdx square, and we apply long formula, this formula, square root of sigma fdx square divided by n, small capital N, minus sigma fdx divided by capital N squared. We are taking here one example. You can see, find out standard deviation of the income earned by worker of an industry. These are income slab 5, 10, 15, 20, 25, 30, 35, and this is frequency, number of worker, this is 2, 7, 11, 15, 10, 4 and 1. Here income is mentioned in 1000. Okay, we are arranging it in that format. You can see income earned we written here, and number of frequency is this, and then we find deviation x, variable x minus assumed mean. You can see this. Okay, we assume 20 as a assumed mean, and then after we find deviation, and then after frequency multiplied by dx, 5 multiplied by minus 20, we will get minus 30, and likewise we can find it. And then fdx square, how we will get it? Fdx multiplied by dx, then minus 15 minus 30 multiplied, and we will get 450, and then we will totaling it, and we will find sigma fdx square equal to minus 50, sigma fdx square equal to 2300, and n equal to 90. We apply long formula, square root of sigma fdx square and sigma fdx square squared divided by n minus sigma fdx divided by n whole square, and then after we will put the value and we will solve it, and then we got square root of this value equal to 6.708, and suppose we want to find coefficient of standard deviation, we apply standard deviation divided by mean. Standard deviation is this, and mean we can easily find by this formula, mean equal to assumed mean plus minus sigma fdx divided by n. This is indirect formula, and our mean is 19 of this series, and we will get coefficient of standard deviation equal to 0.353. Friends, I hope by this I am able to define standard deviation, and you are getting the concept and use of standard deviation. Thank you.